and thank you for joining me today. My name is Anthony Rodriguez, and I'll be presenting a fundamental overview of DevOps. This presentation is designed to provide a comprehensive summary of our recent discussions on transitioning from legacy development models to a modern collaborative framework. We will explore how integrating our development and operations teams through automation and shared responsibility can drive faster delivery and better reliability for our organization. The goal for today is to outline the cultural, technical, and operational shifts required to align our engineering efforts with our strategic business needs. To ensure we provide a clear roadmap for everyone, this agenda follows the strategic progression of our DevOps implementation. We'll begin by defining what DevOps means for our organization and why the transition is necessary for our long-term growth. From there, we will dive into the specific cultural shifts and technical requirements, such as version control and automated testing, that form the backbone of our new infrastructure. We will conclude by looking at the operational techniques and infrastructure components that allow us to maintain a consistent, high-performing delivery pipeline. Traditionally, development and operations worked in separate silos, with development handing software off to operations in a linear, waterfall-style process that often causes delays and deployment issues. DevOps breaks down this separation by uniting development and operations through collaboration, automation, and shared responsibility, which directly supports agile and lean principles by enabling faster delivery, continuous improvement, and better alignment with customer needs. DevOps provides business benefits such as faster software delivery, improved reliability, reduced downtime, and increased competitiveness, which can lead to measurable performance improvements. The main trade-offs include upfront costs for new tools, automation, and employee training, as well as the time required to change processes and culture. But these short-term investments are generally outweighed by long-term efficiency, quality, and business gains. Unlike traditional development approaches, DevOps focuses on collaboration and automation. Previous development approaches focus on a waterfall approach that put too much emphasis on individual teams. This would cause delays and uncertainty for the customer, as the customer would have to wait until each individual team would finish their portion of the project before giving feedback. With DevOps, these teams combine into a more collaborative system. This allows for instant feedback and quicker releases as the team can work together on smaller sprints instead of the whole project. This also allows for the ability to be presented to the customer multiple times for feedback with the ability to adjust where needed. Organizations should focus on building a culture of trust, collaboration, and shared ownership, where teams move away from blame and instead view failures as learning opportunities. Emphasizing transparency, blameless postmortems, and continuous improvement will help reinforce accountability for the entire system and support successful DevOps adoption. We measure success using DORA metrics: deployment frequency, lead time for changes, time to restore service, and change failure rate. The automation process begins at the creation stage, where developers write unit tests alongside their code to ensure individual logic blocks function perfectly in isolation. These tests then transition to the continuous integration pipeline, running automatically on every save to provide a safety net through regression testing. Ultimately, automation serves as the final gatekeeper and a constantly evolving asset, either authorizing seamless deployments or rejecting releases to maintain system integrity as features grow. Being able to recreate environments at any time ensures the development, testing, and production stay identical. This consistency helps teams find bugs faster and recover quickly if a system fails. Using a lab environment for testing also provides a safe fallback state if a new update causes problems. For a successful continuous integration setup, the team must commit to a shared version control repository where everyone pushes small, frequent updates to keep integration simple. This technical foundation must be supported by an automated pipeline that builds and tests code immediately to catch errors early, coupled with a consistent environment to ensure results are predictable. Ultimately, CI relies on a disciplined culture where developers prioritize fixing broken builds over adding new features, ensuring the software remains stable and ready for deployment at all times. To support continuous integration, the team utilizes a layered testing approach that balances speed and human intuition. Automated unit, integration, and regression tests serve as the primary defense by catching logic errors and compatibility issues immediately after code is merged. These are supplemented by automated end-to-end tests to verify the entire user journey, while manual testing remains essential for exploratory sessions, usability checks, and user acceptance testing, where human judgment is needed to find edge cases that scripts might miss. To support a DevOps model, our organization must transition from manual management to an automated software-defined environment. Our infrastructure will center on 4 core pillars: continuous integration and deployment, or CI/CD. We will implement automated pipelines using tools like Jenkins to act as a digital assembly line, ensuring rapid and reliable software delivery. Infrastructure as code and cloud. By utilizing Terraform and cloud providers like AWS, we will manage our servers and networks through code rather than manual configuration, allowing for immediate scalability. Containerization and orchestration. We will use Docker to ensure consistent environments across development and production, managed by Kubernetes for robust orchestration. Monitoring and version control. We will maintain a single source of truth via Git and deploy real-time monitoring dashboards to instantly alert the team to performance issues or service outages. To support a DevOps culture, our organization will adopt a proactive, automation-first operational strategy centered on the following key techniques. CI/CD. Developers will merge code into a shared repository multiple times a day. This ensures errors are caught early through automated testing and allows for frequent, reliable software updates. Infrastructure as code. We will use tools like Terraform to treat our infrastructure like software. This ensures our environments stay consistent, repeatable, and easy to manage without manual configuration. Shift left security. Security is no longer a final step. We will integrate security checks and compliance testing at the very beginning of the development cycle to mitigate risks early. Proactive monitoring and feedback. By implementing continuous monitoring and robust incident management, we can maintain high system availability and use real-time data to quickly identify and resolve performance bottlenecks. Containerization and consistency. Using Docker ensures that the application environment remains identical from a developer's laptop all the way to the production server, eliminating the "it works on my machine" problem. In summary, transitioning to DevOps is more than just adopting tools like Docker or Terraform. It is a fundamental shift toward a culture of trust and shared responsibility. By integrating automated testing and continuous delivery, we transform the software lifecycle from a slow, siloed process into a high-speed digital assembly line that prioritizes quality and reliability. Ultimately, this evolution allows us to move away from the blame game and toward a model of continuous improvement, where we use real-time data to drive value for our customers more efficiently than ever before. Thank you very much. Hello, everyone.